All right, we want to take the integral of this thing, so and I'm really just going to take the integral of each piece. So when I integrate this one, what am I going to get?
P to the third over 3.
Yep. Minus this one.
Minus 2t.
2t. All right, and I need to evaluate that from -1 to 1. All right, so we plug the 1 in there, and I'm going to get 1/3 minus 2 minus, when I plug the -1 in there, I'm going to get -1/3 plus 2. All right, so here I'm going, this would be, well, let's just do this first. Plus 1/3 minus 2. All right, so I get a -4 plus a 2/3. So it's going to be -3 1/3. Which kind of makes sense because when you think about it, what's that going to look like anyway? Graph-wise. What shape is it?
Gravel.
What's the -2 do to it?
Moves it down so it can be below this.
Yep, so in between -1 and 1, it's all going to be below the x-axis anyway, so it makes sense that it would be kind of a large negative number. Good. 28. All right. This one's not as bad as it looks. I'm going to do a substitution here. What is this? If this.
Oh.
So what can I substitute in for 1 minus sine squared? Cosine squared. What's cosine squared over cosine squared? 1. So when I take the integral of that, integral of 1, I'll just get theta. And then I'm supposed to evaluate that from 0 to pi over 4. So I'm going to get 0 minus pi over 4, which is negative pi over 4. Okay. That was not as bad as it looked. And this one, which was similar to one that we did yesterday, because what's the integral of secant squared? Tangent. So I'm going to get the tangent of x from negative pi over 6 to regular pi over 6. So I need to have tangent of negative pi over 6 minus tangent of pi over 6. Well, pi over 6 is 30, so this is my first one. Tangent would be opposite over adjacent. Oops, this is negative. So I'm going to get -1 over radical 3, which is negative radical 3 over 3. Minus tangent of pi over 6. So that's going to be positive pi over 3. I'm sorry, positive radical 3 over 3. So I'm going to get -2 radical 3 over 3. Any other ones?
Yeah. Oh, let's start with 43. All right.
You want to see 43?
Sure. Yeah. I was thinking 41, but we have to do that. So.
Okay, and this one says find the value c guaranteed by the mean value theorem for integrals for the function. All right, so this is the mean value theorem one, so this is basically doing the same thing. Except we'll have that little extra part out in front, little fraction. So of the 1 over b minus a out in front of my integral. And I'm going to change that to be a fractional exponent so that it's easier to take the integral of. So I still got my 1/2 out in front here. And I got to take the integral of this, so that's going to get me x squared over 2 minus 2. This is going to be x to the 3 halves over 3 halves. And we'll fix that in a second. And then this whole thing I have to take from 0 to 2. All right, let's clean this up a little bit. This is going to get me 4/3 x to the 3 halves. This way. All right, what's going to happen when I plug in my 0? What will I get here?
0.
Yep, and here. So 0 minus whatever I get when I plug in my 2. So I'm still going to have that 1/2 times 4 over 2, which is 2, minus. All right, so when I plug my 2 in there, that's the square root of 2 cubed. Doesn't get really any better than that, so we'll just take the square root of 8, right? Which is 2 radical 2 times my 4 over 3. So I'll get 8 radical 2 over 3. 8 radical 2 over 3. All right, and then I multiply my negative 1/2 through there. Negative 1 minus 4 radical 2 over 3. So this would be negative 3 over 3 minus 4 radical 2 over 3. That's negative 3 minus 4 radical 2 over 3. Yep, or whatever the decimal is. I probably could have just found the decimal a long time ago. Any other? All right, this will take us all of like 5 minutes. The second fundamental theorem of calculus is actually pretty easy. Basically, all it's saying here is that if you take the derivative of an integral, you get the function. So the derivative and an integral cancel each other out, much the same way as addition cancels out subtraction, multiplication cancels out division, inverse sine cancels out sine. Yeah. So you're really not doing anything different here. Now the only difference in this problem is I have variables that are t's, but I'm going from 0 to x, so it's an indeterminate amount of space between 0 and whatever. You're still going to plug that in and then simplify it. So you're really not going to do anything differently until your last step when you start plugging in the numbers. They're not all going to be numbers. You're going to have a 0 and an x this time. So let's just take the integral of this one first. What do I do here? What do you take the derivative of to get cosine? No, regular sine. So sine of t, and then I got to evaluate that from 0 to x. So we plug in the 0, so I'm going to have sine of 0 minus sine of x. What is sine of 0? 0. So 0 minus sine of x is negative sine of x.
So is that it, or is that?
That's it. So you're really just doing the same thing that you were doing before. Yeah, except you should probably do them in the right order. It's this one minus this one. Positive sine of x. Enter. Yeah, this one would have made a lot more sense if I would have put the whole problem in here. Duh. That's supposed to have, you're supposed to be evaluating the derivative of the integral of that function. Well, what's it going to end up being? The function. Duh. All right. And then this one's a lot like the first one. Again, you're going to take the integral of the function first, and then we'll plug this stuff in. So integral of cosine of t. In other words, what do you take the derivative of to get cosine of t? Sine of t. And then I have to evaluate that from pi over 2 to x cubed. So I'm going to get sine of x cubed minus sine of pi over 2. Now sine of x cubed, I really can't do anything about that, but sine of pi over 2, that has a value. What is that? 1. So I'm going to get sine of x cubed minus 1. Pretty easy. All right. Homework. Page 293, 75 through 92. And the next 2 days are 4.5, some U substitutions, and then we'll take a quiz on Friday. All right, so this looks really complicated, but a lot of people really like these problems for a number of reasons. Usually kids like this problem because my final formula is like one added constant away from me being fired, right? Because you have FU plus C, right? So if we just threw one more constant in there, I'd be in a lot of trouble. But basically, it's going to widen the amount of like the complex problems that I'm going to be allowed to do, because we're going to have we wouldn't normally be able to do one that was like an x squared plus 1 quantity squared. I'd have to FOIL that out and then take the integral of it, right? But now we're going to be able to do it because this is basically allowing us to do problems that are what do they call composite functions, right? Functions within functions. Right, so they're going to get a little bit more complicated on the inside. But it's really not that bad. So all they're saying here is if you have an integral, as long as this thing is differentiable, which means that it's going to be continuous everywhere on its interval, and doesn't have any sharp points or any breaks or anything like that. If you have the integral of a function within a function with its derivative out here, you can break that up. So essentially, we're going to let the inside part be u, and then we're going to have to figure out what du is, and then make our substitution. All right, so if you're looking at this one, and I always think that it's pretty easy to decide what your u is going to be. So what should we let u equal in this problem? No, maybe it's not that easy. That's the other part. Okay, it's usually the inside part. So like if I had my f of g of x, my outside function would be x squared. My inside function is x squared plus 1. Remember back in pre-calc when we had to do that? We had to define what was the inside and what was the outside. That's exactly what we're doing here. And you want u to be the inside. So that's going to be my x squared plus 1. All right, so right now my problem is going to look like this, u squared. Right, because I'm going to let this get substituted in for the x squared plus 1. And that I know how to take the integral of right now. That's easy. But I still have this part floating around. So where did that come from? Well, take the derivative of u. Because I can't have u's and x's in the same problem. That's not going to work. So if I take the derivative of this side, that means I also have to take the derivative of this side. What is the derivative of x squared plus 1? Mm-hmm. dx, because it's with respect to x. In other words, and that's not really why that dx is over there. because if I take the derivative of u with respect to x, I would get 2x, right? If I cross multiply, I'll get du equals 2x dx. Right? Well, this is right here. So what can I substitute in for all of this? Du. Right? And now it looks like it makes sense because don't I normally, when I'm taking the integral of something, I have the function with the variable in it, dx. Now I have the integral of the variable u du. And this was actually squared. All right, so we're going to integrate that. So what is the integral of u squared du? Don't think too hard. I'm thinking way too hard. Just take the integral of it, just like you would if it was an x. Of this guy. If you had this.
We're just doing it for the u, not the u squared or anything.
Yeah, the squared's part of it. That's going to be what gets raised up, right? So this is just going to be u cubed over 3.
Yeah, but isn't the whole thing squared though?
No.
Oh.
Nope. Well, the u was, we haven't resubstituted back in yet. We're going to. But we got it down to something that it was easier for us to take the integral of. We do it, and then you plug, now once I have that, now you plug the original u back in so that it's using x's again. Okay, so for the process of these is essentially going to be the same every time. You identify what's the insidemost part of it, you let that be your u. You identify it as u equals the inside stuff. Take the derivative of both sides, so du over dx equals, take the derivative of that side, cross multiply so that your dx ends up on the other side, make your substitutions, integrate it because it's going to be way easier, and then back substitute. All right, so let's try another one here. What do you think is the inside part here? What's that? That's actually the outside part. So the inside part, 5x. So we're going to let u equal 5x. So if I take the derivative with respect of u with respect to x, what will I get here? What is the derivative of 5x? 5. All right, cross multiply. I'm going to get du equals 5 dx. All right, so this, everywhere I see a 5x, I can put a u in for it. So right now I'm looking at this being cosine of u, and then this is supposed to be du out here, but du takes care of 5 and dx, so that takes, this is taking care of this and this. And I've already taken care of this here, so everything's taken care of. So now I have cosine of u du. That's way easy. What did you take the derivative of in order to get cosine? Sine of u plus c. But it wasn't a u, it was a 5x. So maybe the hardest part is identifying what the inside part is. I think you guys can handle the integration and the substitutions. About this one, what will you let be the inside? You're getting better now. X squared plus 1. So if I take the derivative of it with respect to x, I'm going to get 2x. Cross multiply, du is going to equal 2x dx. So when I make this substitution, that's going in there. I'll have my u squared. And 2x dx. All right, well, the dx is taken care of when I throw my du, because du takes care of a dx. It takes care of this x, but it's introduced a 2 that was not in my original problem. So in this du, there's a 2 there that wasn't there before. So I have to fix it. How will I eliminate a 2? Multiply it by a 1/2 out here. That takes care of it. So if you have to put in a little fixer because you end up with a coefficient that you didn't have before, you could just throw a 1/2 out here, and now it's 1 again, and everything's square. Right, so you deal with the 1/2 later. You just take the integral of this, and that's the easy part. So what is the integral of u squared? Yep. Plus c. Well, let's do that in a second. So this is times 1/2, so I'm going to get u cubed over 6 plus c. But it wasn't a u. It was a x squared plus 1. So this is x squared plus 1 cubed over 6 plus c. So much more complicated the things that we can do, but they're really not that bad when you make this substitution. Okay, not too bad. We just have a couple more slides tomorrow to go over for that one. So I'm still gonna, no matter what happens, I'm gonna stick with that quiz being on Friday. But it looks like we might be able to get a review day out of Thursday now, which will be good. All right, so stick with that homework that I gave you guys earlier. Just do the one assignment. Not that. This one. So the page 293, 75 through 92. And then we'll pick up with, finish up that lesson.